Good morning. My name is Brian Hennings with Lynntech, and this morning I'm going to talk to you about an ONR-funded project to develop computer vision camouflage. The title says fooling computer vision classifiers, and we were able to do that as well as fooling computer vision object detectors, and that's what I'm going to talk about in the succeeding slides. Lynntech Inc. is a for-profit small business located in College Station, Texas. We've been around for about 30 years. We have roughly 100 employees across a wide variety of disciplines. We have a facility security clearance, numerous employees with personal clearances. We collaborate readily with industry, DoD prime contractors, national labs, universities. We were awarded the Small Business Administration Tibbetts Award in January of 2017 for our transition success in a NavAir SBIR to develop a training device for pilots and aircrew. We don't have just one business model that we use for the transition of technologies. We have spun out 4 or 5 companies. We've licensed IP. We've formed joint ventures. We've manufactured and sold material. We've sold services. We're currently manufacturing and selling hardware. We're focused on transition, and we're very proud of our transition success. ONR has funded us to develop camouflage that fools or breaks the computer vision classifier. So the object's detected, but it's improperly classified. There's 2 types of attacks, a targeted attack and an untargeted attack. In an untargeted attack, the object, for example, a Humvee, is detected, but it's classified as anything other than a Humvee, and that's easier. In the targeted attack, you choose what it's misclassified as. So we will develop a camouflage pattern so that the Humvee is detected, but it's classified as a Toyota pickup. Now the intent is to fool our adversary's computer vision classifier, but we don't know which classifier they're using, which computer vision system. So what we have to do is show that we can fool 5 or 6 or 7 different computer vision classifiers to have a measure of confidence we can fool any computer vision classifier. What the Navy needed was a camouflage pattern that worked in the visual spectrum, that fooled or broke the object classifier, that worked from a variety of ranges and elevations and perspectives on the target. And to date, we have shown all of that. We are still quantifying our success rates from all ranges and all perspectives on the target vehicle. But we do not stop at the visual spectrum. We have preliminary results showing success in spectra other than visual. We didn't stop at just the classifier. We have shown that we can defeat the object detector. So that's what's called an invisibility attack. The computer vision system doesn't even identify an object. It blends into the background. It's the same premise as a military uniform or a camouflage paint job on a military vehicle designed to trick the Mark I human eyeball into not even detecting the object. And so we have developed a camouflage pattern that we were able to apply to a Humvee, and the computer vision object detector didn't even detect the Humvee. It blended into the background, and it blended into the background for several different widely varying backgrounds. So one camouflage pattern worked for various different backgrounds. In addition to that, we've spent a lot of time learning how computer vision classification systems and computer vision detection systems work, and we've developed quite a bit of knowledge and experience in preventing a decal or preventing an adversarial attack from fooling the computer vision system. So we have learned how to defeat or undo what ONR is funding us to do to our adversaries' computer vision systems. Here's how we do it. So it's a 3-step process. We start in cyberspace. We'll take a 2-dimensional image of the Humvee. We will generate a digital pixelated camouflage pattern Based on our understanding of how computer vision systems work, we have a good starting point. We will apply it to the image, and then we'll feed that image into various different computer vision systems until we have success in the Humvee not being classified as a Humvee. Success is not defined as there's a 0% chance that's a Humvee. Success is defined as the Humvee is the fourth most likely or fifth most likely object it's classified as, or it's an 8% chance it's a Humvee, or whatever that number is, but that's success. So once we've iterated and we have success in the stage 1 cyberspace two-dimensional image, we will print the decals and we'll apply them to a physical model of the Humvee. We'll then take a camera from various different perspectives and elevations and ranges, and we'll take imagery, we'll feed that again into several different computer vision classifiers, and we'll iterate on the camouflage pattern until we achieve success in the stage 2 model. I previously mentioned a successful invisibility attack with a Humvee. That was done on a stage 2 model. Then the third and final proof of the pudding is a full-scale demonstration in the field where we print full-scale camouflage decals, we apply them to the vehicle, and then we'll fly a UAV with a computer vision classifier, preferably military grade classifier, and we'll see what it's classified as. We have done field tests on vehicles successfully with military grade classifiers, but we've never done a Humvee. We've done a Toyota Corolla, for example, but not a Humvee. So that's the next step. Now the imagery in this slide is about a year old. So the decals and the camouflage patterns we're developing today blend in with the vehicle and you can't tell that they're applied. So what we have synthesized for in the Humvee example is a camouflage pattern that fools, the same camouflage pattern fools the human eyeball and the computer vision system. So that's a holy grail for the camouflage patterns. We are in the second year of the phase 2 project. We are focused on doing a full-scale live demo using a military grade computer vision classifier. As I mentioned, we're quantifying our success rates at varying ranges and varying perspectives. And you can see what's ahead in the future, but our focus right now is to have a successful field demonstration on an actual military vehicle. I think the advantages and benefits of what we're doing are obvious. If you can fool your adversary's computer vision classifier, that clearly gives you an advantage. If you can learn how to prevent your own computer vision classifiers and object detectors and ATRs from being fooled, that gives you an advantage. The unitary camouflage pattern that can trick both a computer vision classifier and a human, I believe the benefit to that is obvious. And so we're excited about what we're developing. As I mentioned, we're funded by Office of Naval Research. The expected acquisition program is PEO Land Systems within the Marine Corps. Obviously, the Army would be interested in the camouflage patterns we are developing, and for that matter, anyone else developing military vehicles and military equipment. And as far as preventing the fooling of computer vision systems, anyone dealing with automatic target recognition, computer vision object detectors and object classifiers would be interested in what we're doing. Lynntech is looking for partners to help transition this technology and knowledge. We're looking for entities in military vehicles or military equipment, folks that deal with camouflage patterns, camouflage, and people that are working in automatic target recognition, computer vision classification, computer vision detection. We are looking to talk to them. We're looking to partner with them to transition this technology. Here is my contact information. Both myself and Dr. Jason Hill, our subject matter expert, would love to talk to you more about what we're doing, answer any questions you may have, show you additional information. We believe in this technology. We are excited about it. We think it offers a clear tactical and strategic advantage to our military forces, and we are just excited that we have this opportunity to share what we're doing. We hope to talk to you further. Thank you.